NEC section 680.25 outlines the requirements for feeders supplying power to swimming pools. The core principle is that these feeders must be installed within raceways, such as Conduit. This measure enhances safety by providing a robust protective barrier against physical damage and environmental factors, reducing the risk of electrical hazards in and around the pool area. However, there is an exception to this rule specifically for feeders installed in 1 and 2 family dwellings. This means that if a swimming pool is directly associated with a single-family home or a duplex, the feeder supplying power to the pool might not be required to be encased in conduit, provided that it meets other applicable requirements of the National Electrical Code. It is very important to understand the nuances of this exception, as it doesn't automatically apply to every residential pool installation. Now consider a scenario where a pool is powered from a subpanel located in an outbuilding that is separate from the main dwelling. In such cases, the exception for 1 and 2 family dwellings typically does not apply. The rationale is that the outbuilding is not considered part of the dwelling itself, and therefore the feeder from the outbuilding's subpanel to the pool panel must be installed in conduit. This requirement is strictly enforced to ensure that the electrical wiring to the pool is adequately protected, regardless of its proximity to the main house. If an electrical inspector has flagged an installation for not complying with section 680.25, it is crucial to understand the basis for their decision. In many cases, the issue arises from the interpretation of whether the feeder is indeed exempt under the 1 and 2 family dwelling exception. If the feeder runs from a subpole in a detached building, the inspector is likely to require conduit installation to meet code requirements. When faced with such a situation, several solutions can be considered. Firstly, the most straightforward approach is to install conduit for the feeder running from the subpole to the pool panel. The conduit can be either buried directly underground at the correct depth per the NEC, or it can be run through the walls or ceiling of the outbuilding, ensuring it is properly supported and protected. Secondly, it's important to use the correct type of wire for the installation. For direct burial applications within the conduit, THWN or XHHW conductors are commonly used and suitable as they are rated for wet locations. The size of the conductors must be appropriate for the load they will be carrying, and they must be protected by an appropriately sized overcurrent protection device, such as a circuit breaker or fuse. Thirdly, ensure that all grounding and bonding requirements are met. The National Electrical Code has specific requirements for grounding and bonding of swimming pool equipment and electrical systems. These requirements are intended to minimize the risk of electric shock and ensure that the electrical system is properly grounded. This includes bonding all metal parts of the pool structure, such as the reinforcing steel in the concrete, the metal pool equipment, and any metal fences or enclosures around the pool. The bonding conductors must be sized and installed according to the NEC. Let's delve further into the specifics of conductor selection for pool feeders. When running conductors in conduit, it's crucial to choose the correct type of wire that is rated for wet locations, as conduit can often accumulate moisture. THWN and XHHW are 2 common types of conductors that are suitable for such applications. THWN is a thermoplastic high water resistant nylon coated wire, while XHHW is a cross-linked polyethylene high heat and water resistant wire. Both are excellent choices for use in conduit, providing reliable insulation and protection against moisture. The size of the conductors is another critical factor. The conductors must be sized to carry the load of the pool equipment, taking into account any motors, heaters, or lighting that will be connected to the pool panel. The National Electrical Code provides tables that specify the ampacity of different sizes of conductors based on their insulation type and the ambient temperature. It's important to consult these tables to ensure that the conductors are adequately sized for the load they will be carrying. The overcurrent protection device, such as a circuit breaker or fuse, must also be sized appropriately to protect the conductors. The overcurrent protection device should be sized no larger than the ampacity of the conductors, as specified in the National Electrical Code. This ensures that the conductors are protected from overloads and short circuits, which could cause them to overheat and potentially start a fire. In addition to conductor selection and overcurrent protection, grounding and bonding are essential for electrical safety around swimming pools. Grounding is the process of connecting the electrical system to the earth, providing a path for fault current to flow back to the source, tripping the overcurrent protection device and energizing the circuit. Bonding, on the other hand, is the process of connecting all metal parts of the pool structure and equipment together, creating an equipotential plane that minimizes the risk of electric shock. The National Electrical Code has very specific requirements for grounding and bonding of swimming pools. These requirements include bonding all metal parts of the pool structure, such as the reinforcing steel in the concrete, the metal pool equipment, and any metal fences or enclosures around the pool. The bonding conductors must be sized and installed according to the NEC, and they must be connected to a common bonding grid. Furthermore, any electrical equipment located near the pool, such as pumps, filters, and heaters, must be properly grounded. This typically involves connecting the equipment to a grounding electrode, such as a ground rod or a metal water pipe, using a grounding conductor of the appropriate size. It is vital to adhere strictly to these grounding and bonding requirements to ensure the safety of anyone using the swimming pool. Consider the specific requirements outlined in NEC Article 680 regarding swimming pools, spas, and hot tubs. This section of the code is dedicated to addressing the unique electrical safety concerns associated with these environments, where water and electricity can create hazardous conditions. Article 680 covers a wide range of topics, including wiring methods, grounding and bonding, equipotential bonding, and the location of electrical equipment. One of the key requirements in Article 680 is the use of ground fault circuit interrupters, often called GFCIs. GFCIs are designed to detect small imbalances in the current flowing through a circuit and to quickly trip the circuit if a ground fault is detected. This can prevent electric shock by cutting off the power before a person comes into contact with a live electrical conductor. The National Electrical Code requires GFCIs to be installed in numerous locations around swimming pools, including for receptacles, lighting, and electrical equipment. Another important aspect of Article 680 is the requirement for equipotential bonding. Equipotential bonding involves connecting all metal parts of the pool structure and equipment together with a bonding conductor. This creates an electrical path that ensures that all metal surfaces are at the same electrical potential. This minimizes the risk of electric shock by preventing voltage differences from developing between different metal surfaces that a person might come into contact with. Article 680 also specifies the minimum distances that electrical equipment must be located from the pool. This is to prevent electrical equipment from falling into the pool or being splashed with water. The National Electrical Code specifies different distances for different types of equipment depending on their voltage and construction. For example, receptacles must be located at least 10 feet from the inside wall of the pool, while lighting fixtures must be located at least 12 feet above the maximum water level. It is important to carefully review and understand all of the requirements in Article 680 before installing any electrical equipment around a swimming pool. Failure to comply with these requirements can result in serious electrical hazards. If there is any doubt about the correct way to install electrical equipment around a swimming pool, it is always best to consult with a qualified electrician. Let's discuss the practical steps involved in installing conduit for a pool feeder. Firstly, planning the route is crucial. Determine the most direct and practical path for the conduit from the subpanel and the outbuilding to the pool panel. Consider factors such as the location of underground utilities, the slope of the land, and any obstacles that might impede the installation. Secondly, select the appropriate type and size of conduit. Rigid metal conduit, intermediate metal conduit, and electrical metallic tubing are all acceptable choices for pool feeders depending on the specific application and local code requirements. The size of the conduit should be large enough to accommodate the conductors that will be installed inside, with sufficient space for easy pulling. Thirdly, dig a trench. If the conduit will be buried directly underground, dig a trench that is deep enough to meet the minimum burial depth requirements specified in the National Electrical Code. The depth will vary depending on the voltage of the circuit and the type of conduit being used. Generally, A minimum burial depth of 18 inches is required for rigid metal conduit and intermediate metal conduit. Fourthly, assemble the conduit run. Cut the conduit to the appropriate lengths and connect the sections together using couplings and connectors. Make sure all connections are tight and secure to prevent moisture from entering the conduit. If the conduit run includes bends, use conduit benders to create smooth, gradual bends that will not damage the conductors. Fifthly, install the conductors. Pull the conductors through the conduit, making sure they are not twisted or damaged. Use a pulling lubricant to reduce friction and make the pulling process easier. Leave sufficient length of conductor at each end of the conduit for making connections to the subpanel and the pull panel. Sixthly, backfill the trench. Once the conductors are installed, backfill the trench with soil, making sure to compact the soil around the conduit to provide support and protection. Seventhly, make the electrical connections. Connect the conductors to the subpanel and the pull panel, following the manufacturer's instructions and the requirements of the National Electrical Code. Make sure all connections are tight and secure, and properly insulate any exposed conductors. Finally, inspect and test the installation. Once the conduit run is complete and the electrical connections have been made, it is important to inspect and test the installation to ensure that it is safe and compliant with all applicable codes. A qualified electrician can perform a variety of tests, including continuity tests, insulation resistance tests, and ground impedance tests. These tests will verify that the wiring is properly installed, that the grounding system is functioning correctly, and that there are no potential electrical hazards. Let's consider a scenario where the existing wiring from the main house to the outbuilding is aluminum. When dealing with aluminum conductors, special considerations must be taken to ensure safe and reliable connections. Aluminum conductors have a higher coefficient of thermal expansion than copper conductors, which means that they expand and contract more with changes in temperature. This can cause connections to loosen over time, leading to increased resistance, overheating, and potentially even fires. To prevent these problems, it is important to use connectors that are specifically designed and listed for use with aluminum conductors. These connectors are typically made of aluminum or aluminum alloy and are designed to maintain a tight connection even as the aluminum conductor expands and contracts. The connectors should be installed according to the manufacturer's instructions, using the correct torque settings. An antioxidant compound should be applied to the aluminum conductor before making the connection. This compound helps to prevent oxidation of the aluminum, which can increase resistance and reduce the effectiveness of the connection. The antioxidant compound should be applied liberally to the conductor and the connector, ensuring that all surfaces are coated. Regular maintenance is crucial. Aluminum connections should be inspected periodically to ensure that they are still tight and secure. If any loose connections are found, they should be tightened immediately, using the correct torque settings. It is also a good idea to reapply the antioxidant compound to the connections every few years to prevent oxidation. When connecting aluminum conductors to copper conductors, it is important to use connectors that are specifically designed for this purpose. These connectors are typically made of a bimetallic material such as aluminum and copper, and are designed to prevent galvanic corrosion. Galvanic corrosion can occur when two dissimilar metals are in contact in the presence of an electrolyte, such as moisture. The electrolyte causes one of the metals to corrode more rapidly than the other, which can weaken the connection and eventually lead to failure. Bimetallic connectors prevent galvanic corrosion by providing a barrier between the two metals, preventing them from coming into direct contact. It's important to consider the importance of documentation. Keep detailed records of all electrical work that is performed, including the type and size of conductors used, the type of conduit installed, the location of all electrical equipment, and the results of any testing that is performed. This documentation can be invaluable for future maintenance and repairs, and it can also be helpful in resolving any disputes with the electrical inspector. The documentation should be kept in a safe and accessible location where it can be easily retrieved when needed. Consider labeling. Label all electrical panels, circuits, and equipment clearly and accurately. This will make it much easier to identify the correct circuits and equipment when performing maintenance or repairs. The labels should be durable and weather-resistant so that they will not fade or deteriorate over time. When labeling circuits, it is important to use a consistent naming convention so that the labels are easy to understand and remember. For example, circuits could be labeled according to the area they serve, such as kitchen lights or living room receptacles. Let's consider some common mistakes to avoid during a pool feeder installation. Firstly, undersized conductors is a common mistake. Using conductors that are too small for the load they will be carrying can cause the conductors to overheat, which can damage the insulation and potentially start a fire. Always consult the National Electrical Code to determine the correct size of conductors for the load. Secondly, improper grounding and bonding is a very dangerous mistake. Failing to properly ground and bond the pool structure and equipment can create a shock hazard, which can be fatal. Always follow the grounding and bonding requirements in the National Electrical Code. Thirdly, using the wrong type of conduit is another mistake to avoid. Using conduit that is not rated for the environment in which it is installed can cause the conduit to corrode or deteriorate, which can expose the conductors to moisture and damage. Always use conduit that is rated for the specific application, such as rigid metal conduit for direct burial or electrical metallic tubing for indoor use. Fourthly, loose connections can lead to fire. Failing to tighten connections properly can cause them to loosen over time, which can increase resistance, overheat, and potentially start a fire. Always use the correct torque settings when tightening connections and inspect the connections periodically to ensure that they are still tight. Fifthly, failing to protect conductors from physical damage. Conductors that are exposed to physical damage, such as from lawnmowers or digging equipment, can be damaged, which can create a shock hazard or a fire hazard. Always protect conductors from physical damage by installing them in conduit or burying them at the appropriate depth. Let's consider the role of permits and inspections in electrical work. Electrical permits are required for most electrical work, including the installation of a pool feeder. The purpose of an electrical permit is to ensure that the work is performed safely and in accordance with the National Electrical Code. The permit process typically involves submitting a set of plans to the local building department for review and approval. The plans should show the scope of the work, the location of all electrical equipment, and the wiring methods that will be used. Once the plans are approved, the permit is issued and the work can begin. Electrical inspections are typically required after the work is completed. The purpose of an electrical inspection is to verify that the work has been performed in accordance with the National Electrical Code and that it is safe to energize the circuit. The inspector will typically check the wiring methods, the grounding and bonding system, the overcurrent protection devices, and the labeling of the electrical panels and circuits. If the inspection is successful, the inspector will issue a certificate of compliance, which allows the electrical system to be energized. It is important to obtain all necessary permits and inspections before beginning any electrical work. Performing electrical work without a permit is illegal and can result in fines or other penalties. It can also void the homeowner's insurance policy in the event of a fire or other electrical accident. Moreover, it is important to use a qualified electrician for all electrical work. A qualified electrician has the knowledge, skills, and experience to perform the work safely and in accordance with the National Electrical Code. Using an unqualified person to perform electrical work can be dangerous and can result in serious injury or death. Also, it is key to stay updated with code changes. The National Electrical Code is updated every 3 years, so it is important to stay updated with the latest changes. The changes to the National Electrical Code can affect the way that electrical work is performed, so it is important to be aware of these changes and to comply with them. The National Electrical Code is available for purchase from the National Fire Protection Association, and it can also be accessed online. Moreover, there are numerous training courses and seminars available that cover the National Electrical Code and other electrical safety topics. Let's delve deeper into understanding the specific requirements for conduit types. The National Electrical Code recognizes several different types of conduit that can be used for electrical installations, each with its own unique characteristics and applications. The most common types of conduit include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, rigid polyvinyl chloride conduit, and flexible metal conduit. Firstly, rigid metal conduit is the thickest and most durable type of conduit. It is typically made of steel or aluminum and is used for applications where the conduit will be exposed to physical damage or corrosive environments. Rigid metal conduit can be buried directly underground, and it can also be used for exposed applications. Secondly, intermediate metal conduit is a thinner and lighter version of rigid metal conduit. It is typically made of steel and is used for applications where the conduit will be exposed to moderate physical damage. Intermediate metal conduit can be buried directly underground, and it can also be used for exposed applications. Thirdly, electrical metallic tubing is the thinnest and lightest type of conduit. It is typically made of steel or aluminum and is used for applications where the conduit will not be exposed to physical damage. Electrical metallic tubing is typically used for indoor applications, such as in walls and ceilings. Fourthly, rigid polyvinyl chloride conduit is a non-metallic type of conduit that is made of polyvinyl chloride plastic. It is typically used for applications where the conduit will be exposed to corrosive environments, such as in swimming pools or chemical plants. Rigid polyvinyl chloride conduit is not suitable for use in locations where it will be exposed to physical damage or high temperatures. Fifthly, flexible metal conduit is a flexible type of conduit that is made of steel or aluminum. It is typically used for applications where the conduit needs to be bent or flexed, such as when connecting to motors or other equipment that vibrates. Flexible metal conduit is not suitable for use in locations where it will be exposed to physical damage or corrosive environment. The National Electrical Code specifies the types of conduit that are permitted for different applications. It is important to consult the National Electrical Code to determine the correct type of conduit for the specific application.